Welcome to e-lecture online. Today we shall be considering a topic in physics called computational physics. Now in this course we are going to be covering some part of this course. Now we will be looking at numerical solutions on how to find the roots of some functions using a method called the Newton-Raphson method. Now in the Newton-Raphson method, there are some steps that we need to take in order to solve successfully the roots of a particular function. So first we are going to select an initial point as an initial guess. So in that we are going to compute into this formula that I will write that will give us the edge in order to find the root of the equation. Mind you, this initial guess will continue to give us some set of numbers until two of those preceding numbers are alike, then we stop. So at that point, it is the root of that particular function. Let's begin. Now, written on the board is what I call the Newton-Raphson algorithm that is used in finding the root of some functions. Now, I'm going to define all the terms that is here on the board. Xi plus 1, I assumes a natural number, and I tells us our initial guess. So we can start our initial guess from 0, 1, 2, 3, 4, as the case may be. And f of xi is our function at xi, meaning that if the initial guess we take as I equals to 0, I'm going to insert f of x of 0 and get the function and divide it when I find the derivative of that function, and I insert the initial guess at the derivative of that point. By the time I compute this, then I'm going to find a numerical value, and that numerical value will be used as the next initial guess until I get two preceding values that tally, then I'll stop. At that point, it is the root of that particular function. That is the algorithm we are going to use. So next we are going to solve a problem using this technique, and we will see how it will converge to be the root of that particular function. So the question on the board said we should use the Newton-Raphson algorithm to find the real root near 2 of the function x raised to the power 4 minus 11x plus 8 equals to 0, correct to 5 decimal places. Now, from this question and from the Newton-Raphson algorithm, you will discover that our initial point of guess xi becomes 2. So instead of xi, it becomes x naught. X naught is our 2. So, and also we can also find the solution to this problem using the table value. We can actually have a table, and we are going to keep computing results till we find those two numbers preceding that almost the same, then we stop. But from the Newton-Raphson algorithm, there are some important things that we need to note. We know that our f of x is a function itself, x to the power 4 minus 11x plus 8. Then f prime of x will be the derivative of this function, and the derivative of this function will give us 4x cubed minus 11x. The derivative of a constant is 0. The derivative of a constant is 0. So we are going to have a table that we are going to use in order to compute this. And like I said initially, we can also solve this problem using Casio calculator, and I'm going to be showing you on how to use it and get this. Don't forget that this problem is a computational problem. So we were supposed to use a MATLAB, but in the absence of MATLAB, we can actually use a Casio calculator. I'm going to teach you how you compute it, then we are there. Now, written on the board is the step-by-step method on how to do this and how to use calculator to compute it. So when you look at the board carefully, you'll see that f of x is equals to x to the power of 4 minus 11x plus 8. And the derivative of that function, which is f prime of x, is equals to 4x cubed minus 11. And using the Newton-Raphson algorithm, you will have that xi plus 1 is equals to x minus f of x all over f prime of x, where xi is the initial guess of the point at which we are looking for. So, but at the other side of the equation, at this side, you will see that I have decided to name this function f of x as a, because when using Casio calculator, we can use alpha a to insert a into it, and also alpha b to get b, and alpha c to get c. So you see that this function ABC, when you compare it to the Newton-Raphson algorithm, you will discover that my c becomes my xi plus 1, my b becomes my f prime of x, and my a becomes my f of x. So it's going to be very easy for me to compute this in the Casio calculator. And on this table, xi is our initial guess, f of x is the numerical value we are going to get if we insert the value of x in this function, and f prime of x is the numerical value we are going to get when we insert the value of x in this function, and this xi plus 1 is going to be the numerical value when we subtract x from f of x and divide by f prime of x. So we are going to do this problem all using a calculator. So let's begin. Get your Casio calculator, sit tight, and follow these steps. Now, this is your Casio calculator. Now, in your Casio calculator, in order to enter a, you press alpha here, alpha, and here is your a. So alpha a, are you seeing? Then in order to insert that equality sign, please do not use this equality sign here. But if you check carefully, there's an equality sign here. So press alpha, then equal to. Are you seeing? Alpha equal to. Then you have to press alpha x raised to the power of 4. Then you go down. Then minus 11. Then alpha x plus 8. Now that is the first equation we have gotten in order to compute it in calculator. So the next is to define the line of codes between A, B, and C. In order to do that is to press alpha and this semicolon. So this meaning that we have defined what A is. So whatever we do next, it will be the codes, line of codes for the other function. So from our board, alpha b is equal to, you put alpha equal to, then we have next is 4, then you press alpha x cube, you go down, then minus 11. This is the second function. So the third function, you have to separate it, the line of code. So alpha, this column, it will separate it. Then alpha c is equal to, then you press your alpha solve is your equal to, then you have to press alpha x minus, please use this division sign here, this particular division sign, divide by, you see. Then what is a? A is our function f of x, which we have called a. We have defined it to be a, so press alpha a, then we go down, then f prime of x, we have already defined it to be b, so alpha b. So if your lines of codes are accurately entered like this, you have to cross-check all you have entered is correct, and if that is correct, just press this button solve. Then it will tell you what is the initial value of x. And you see from the board given to us, they said we should take our x naught equals to 2. Our x naught equals to 2. So from my calculator, the calculator asks me what is the initial guess. So I'll just quickly press 2, then equal to b, just press equal to. There's no need to enter c, no need. Then you see a, becomes our 2. So we're going to start computing that now. So our initial guess, 2, will return f of x 2. But our question said we should correct answer to 5 decimal places, so it becomes 2.0000 to make it 5 decimal places. So next, from the calculator, is to press the equality sign. Then it gives you the f prime of x, which is 21. So we have 21.00000 to make a 5 decimal place. C is 40 over 21. Then you press this button, it gives you 1.90476. That becomes our xi plus 1 from the Newton-Raphson algorithm. So 1.90476. 1, 2, 3, 4, 5. Yes. So now what will be our next initial guess? Our next initial guess will be this value given to us. Number 2. 2 is the initial. So in this algorithm, the final answer here becomes our initial guess here. So please pay attention. So our initial guess now becomes 1.90476. 9.4076. So next is to insert it here. In order to insert it here, you see, if you press the equality sign, it will ask you what is the value of x that we need to impute. So instead of 2, we are going to impute the first answer we got, 1.90476. Then you press equal to. It's going to return you the answer. Please do not enter anything big. No, this is what you are interested at, 0.21082. So this is the function which we are going to be entering. Good. So here becomes 0.21083, approximating to 5 decimal places, 21083. Then equal to, this b will give us 16.64272 to 5 decimal places. So the next is going to give us 1.89201. 1.89209. 1.89209. If you press this equality sign, it will take you back. What is the initial value of x? What you need to do is to enter the final answer we have gotten here as the initial guess here. So let's quickly write it here, 1.89209. So I'm going to enter it here, 1.89209. Then you press equality sign until you have reached f of x. So if you check carefully, this becomes 0.00344. So 0.00344. 3.44, but there's 10 raised to the power minus 3, so it's 0.00344. Then equality sign, this part becomes 16.09476. Then the next, we got 1.89, 1.89, 188. 1.89188. So when you press your calculator equal to, it will show you what is the next value of x. So like I said, this final answer becomes our initial guess, 1.89188. So I'm going to impute it in my Casio calculator, 1.89188 equal to, this is what we are interested in. From here we have 0.00063. 0.00006. 1, 2, 3, 4, 5. Yes, we correct. So the next is to press equal to. Don't forget that our b is our f prime of x, which is 16.08574. The next, we are going to have 1.89188 approximately. Do you see what I'm saying? When you check this to 5 decimal places, becomes 1.8918. This will round this to 8, so 188. 1.89188. So did you notice that approximately these are the same? Like I said, from initial point, they are the same, meaning that the root of this particular function, x squared, x raised to the power 4 minus 11x plus 8 at initial guess x equals to 2 will give us this function. And by the time I said if we have two values almost the same, we stop at that, and that becomes the root of the equation. So this is the root of this equation, this particular, because approximately they are the same. Thank you for watching. Please ensure that you subscribe to my YouTube channel for subsequent videos, share and like. Thank you. See you soon.